following is a
Okay.
conversation with Vinay MS, who is one of the most fascinating people I've met in LinkedIn, because I don't feel like you can really dedicate 10 years of your life in research, probably, and hustle in teaching and also in research. Never saw any person who can really give up this amount of dedication to the research and also work with passion in the same field for a long time. And I'm very glad that Vinay MS sir is in the podcast, and it's an honor to have you in the podcast, sir.
Thank you. Thank you so much for inviting me.
Yes, sir. So let's just start with the question, sir.
Mm. Okay, yeah. You can, you can.
Yeah.
Let's
Okay.
start. Mm.
Okay. Let me just ask you this one question, because you have been working in database management system and lot of other new tech. It can be
Mhm.
your new approach in order to get inside machine learning as a PhD student, or else probably as a professor teaching probability and graph theory and other aspects to the bachelor's and a master's student. Do you really
Mhm.
think that living entities and computer interaction are just a simulation? The same
Are you
question.
talking about are you about interaction between living entities and computers,
Human
or
computer interaction, and also the way they are giving out analog and digital output, and that aspect I'm asking you.
means simulation means, if you see, simulation is something called synthetic. You are synthetically programmed something. So you are basically asking me whether humans interacting with computers is a simulation.
Yep.
Okay. Um, no, I would not say like that, because we use computing to do simulation. We actually simulate the real world using computing, and successfully we have done that very recently. If you see, most of the science today that is happening, experimental science, is no longer happening in laboratories. It's happening in computing systems, simply because you just don't have such sophisticated instruments to do experiments. Biologists have moved to computational biology, physicists have moved to computational physics, chemists have moved to computational chemistry, doctors have moved to computational medicine. The whole science has moved to computation today. Uh, Earlier, you would see laboratories where people would sit and do experiments, mix chemicals, do experiments with light. Today, you cannot. The reason simply is because such kind of engineering does not exist today. For example, when you want to discover Higgs boson, you spend billions, we have spent billions and billions of dollars to build one facility to find a Higgs boson particle. And there are not just Higgs boson, there are hundreds of particles which have been predicted, but they cannot be discovered even today because of the lack of engineering, lack of feasibility in engineering. So I would say computing is a very primary tool today to do simulation, simulating the real world, simulating the quantum world also to some extent, the minute world. So I would say computing itself is a very good simulation tool rather than humans interacting with computers as a simulation. Yeah.
That's a pretty awesome way of justifying that answer, that
Mm.
question, by the way. And like,
Mm.
what's inside a computer architecture? As a database scientist or as a database researcher, what's do you feel that it's there inside a computer architecture, or else what is making that computer a computer, or else how was it different from your era to the present day?
So let us talk about 1960s computing itself, when the world was moving towards um, uh, initially it started doing the computing thing. So it was a time when we had vacuum tubes, right? We did not. It was very big computers, like small addition of two numbers, subtraction of two numbers. You needed a computer which was as big as your apartment, you know? And people used to feed in their programs using punched cards. Okay, uh, people used to stand in queue waiting for their turn to feed their punched card in. And the discovery of transistor, especially silicon transistor, changed the game. I would say silicon transistor is the game changer. That's why we call the word Silicon Valley, giving full respect to the element called silicon, because silicon transistors could ensure that computing becomes more and more compact, more and more compact. Instead of a computers which are big, which would become which were as big as an apartment, now they're as big as a matchbox. right? And I would say game changer is silicon, and that is still going on. If you see from the time when we were studying, um, we were talking about memory devices like floppy and all. Today we talk about a small matchbox level of USB device which stores terabyte of data, all because of the advancement of silicon materials. So I would still say the number one driver for computing technology is the material science. Material science drives future computing. Yeah.
So you talked about the material science, though being a database
Yeah.
researcher, what
Okay.
was that technology that really makes you fascinated even today? Is it still the same old technology which you used to work, or else is it the same technology which you are going to learn, or which made you feel that yes, this technology is going to make a huge disruption in the market? What was it?
Okay. I would say that currently I'm fascinated with the recommender systems that we see today in our own mobile phones, which are so tailor made to our own preferences. They look very fascinating to me because they know what I like. They keep on feeding me the news which I like. And the funny thing is that recommender systems are not perfect. They have enormous scope to be improved. And the only way they can be improved is through AI or machine learning, by machine learning techniques. So, and not just that, they have immense commercial potential also. Uh, well, I have been a prey of recommender systems. You know, like the day when I fell into this prey. I get tempted. They know the recommender systems online. They know what I like, so they keep on recommending me products of those companies which I like. And sometimes I can't control myself, and I just buy them. You know, this is. I'm a very strong-willed person. If I don't have a strong will, I wouldn't have survived so many years of grueling experience. But even then, I will fall prey to this. And think about a normal layman who is not too strong, who has a weak mind, who has a lot of desires. They will create enormous business potential for the companies because of recommender systems. And recommender systems can be dramatically improved by ML techniques. That's what I believe. And that's what I am amazed of today currently. Yeah. Yeah.
So last time you had told, sorry for that last time because we had a lot of technical disturbances. Last time you
Mm.
had told about your experience from 2002 when you joined
Mm.
engineering till
Mm.
the date you are still an adjunct professor. What has really changed in the technology? And I also have this question of what will be the form factor of the technology tomorrow?
Back then, when we joined 2002, when we joined computer science, one thing we thought, see, all of us had good entrance exam ranks. So what do we do? You want to do engineering now, which branch to do? Okay, your seniors are selecting CS, you end up selecting CS, right? Uh, Most probably like that.
I'm an
And back
EC
then we
guy.
thought computing, back then computers were like, we thought there are some big devices, people sit on it and work on it. You know? So it requires some sophisticated training to work on it. Okay. I thought, okay, this is a very specialized system which requires some specialized training to work on it. But we didn't realize that in the next 15 years, computing will go to every common man's hand in the world, your smartphones. Right? We never thought that actually. Never in our wild dreams we thought a computer will go to the hand of every common man in the world. A farmer, a layman, a mason, a painter, everybody are having smartphones today. And that smartphone is a very, very sophisticated computer, right? You can write your programs, you can write latex documents, you can write whatever you want. You can do cloud computing with your phone, right? Anything. And that actually was something amazing. We did not even have a faintest idea. In fact, the appeal of Google also, we thought, okay, it is a small search engine back then which will help us to search some relevant documents. 2002. We thought it was a small search engine. We want to search some websites we don't know. It will help us to search. But little did we realize Google's impact is become so heavy that it's simply become one of the greatest companies in the world today. Right? These are things that amazes me actually from 2002 to now, as of now. Yeah.
Even Martin Cooper, the guy who invented cell phone,
Mm.
actually told that this will never replace the ritualized telephone. That means everybody was so stuck with the telephone that he really thought that it will never be such a big disruptive technology. Like,
Mhm.
I feel like you are one of those people who have been influenced a lot by the technology. Sir, as a faculty and as a researcher, which is the job which has been most satisfactory to you, and how well has it built you today?
Uh, Satisfaction is definitely teaching. When you take a class for an hour, you feel very satisfied. Researcher is more of it's a very ambitious thing, when you are trying to design something which is not there in the world, right? You are trying to design something which is not there in the world. You have become a good visionary guy here. And basically, you are not discovering as an engineering researcher. You are not discovering, you are designing actually. Okay, like scientists discover, we design. So when you're designing something new which is not there in the world, and when you're successful and you are able to get appreciated with that new design, you feel euphoria rather than satisfaction. Okay, so research, I'll say it's more of an ambitious track. Teaching, I'll say it's more of satisfactory track. Yeah. Yeah.
You actually told that your research is kind of a satisfactory, then also the teaching is also one of the satisfactory job, because you are going to teach what you are learning.
Hmm.
So now I
Hmm.
just wanted to ask you that one question: what was life without TensorFlow back in those days, like your experience?
No, actually, what had happened that there were ML libraries available, may not be as sophisticated as what you get today, like TensorFlow and all things. TensorFlow has become a de facto for deep networks today. Back then, deep networks was not even thought of. You know, the most prevalent thing was neural networks, which was not deep in any sense, which had 4 or 5 intermediate layers, hidden layers. Now you have thousands of hidden layers in between the output and input layer of a neural network. That has become deep network now.
And billions of
Now that
parameters.
requires and billions of parameters and billions and billions. Everything is millions and billions now, and craziness has entered a lot. So you need a specialized programming language to take over that complexity. That has become TensorFlow. I understand. Uh, Back then, ML deep networks was very nascent. There were some very simple libraries, and people, and to be frank, people did not give too much importance to ML back then. In the first decade of this century, to be frank, it was picking up, but it was not getting too much importance. To be frank, the next decade, from 2010 to 20, we have seen a revolution happening in ML because everybody are moving towards it. Businesses are exploiting it. Until then, businesses were not exploiting ML actually. So, and it didn't matter when you also, it did not matter because when you did not have TensorFlow, it did not matter because neither the businesses were demanding it and neither academic research was too much behind it. So it was like that. Yeah.
So, you told about your research, because you
Mm.
had been working in IISc as a researcher for 10 years as a project associate. And also you have
Mm-hmm.
been funded with projects which was under the Brazil's government. And also you went for Brazil for fully funded for an as a research assistant there also. So like I just have this one question: what really makes the technology unique today according to you, and also how to approach a problem statement?
Mm-hmm.
Last time when you told more amount of transistors are stacked and there is a lot of number crunching, and I was fascinated about how can it really makes sense, because back in those days it was not about number crunching, it's also about processing, getting the process down with less compute. Today we have the
Mm.
compute, we have more resources of compute, but we are still lacking with the algorithm. What makes it unique according to you?
One thing is, there is no technology that is unique today, to be frank. We all build technology by using the foundations of the past technologies, right? Database systems came into picture because of flat files processing systems that were there in 1970s. In fact, when I think Edgar Card wrote the relational database schema paper for the first time, proposing RDBMS, it was rejected by the journal. And it's a very bizarre idea, in fact. And finally, he was given the Turing Award. I would say no technology is unique. We all build technologies, right? using a lot of previous technologies and concepts. So we should never say any technology is unique. And second, how do you approach the problem statement? It depends what your goal are. Are you looking at business goals, or are you looking at creative goals? Okay, business goals means you're trying to make commercial aspect of, you're trying to exploit commercial. You want to get some commercial benefits out of the project that you will develop. So if that is your goal, then your problem statement should be aligned towards the business goal rather than what technical invention it is doing. Ultimately, the business goal is the prime factor, right? So if you are looking at a business goal, then your problem statement should be written in such a way that the focus is on the business goal and achieving the business goal at all costs. You might have the most beautiful technology, you might have the most sophisticated one, very creative one. If it does not appeal to the people, does not create business, the very purpose of bringing it in for exploiting business is a waste, right? And many technologies have become like that. Many technologies. Your what do you call that? Blueberry, what a BlackBerry mobile phone that came 10 years
Yeah.
behind. Yeah, it was beautiful. You see small keyboard and all, but it's out of the question now. Even in IAC, they developed something called a Simputer, which was a predecessor to your uh, BlackBerry mobile phone. Big flop, right? Ultimately, the business goal is very important. So if you create your problem statement in such a way that business goal should be achieved at all cost, that is better. Now, if you're looking at creative aspects where you want to get some good recognition by solving some tough theoretical problems, you know, then you should look into mathematically well define the problem, okay, so that all constraints and parameters are taken care of. Yeah, thank you.
Sir, last time when we were recording, you also told about the technology which fascinated you was phase shift memory, where you gave an example of a floppy and you gave the
Mm.
example of how the phase shift memory
Right.
is all about. Like back in
Mm.
those days, in
Mm.
2002, when you started out with the engineering, that's a big deal because
Mm.
nothing was feasible according to the availabilities. Now there is an edge. If you were given that edge, the same thumbnails what we have today, probably I can create hundreds of thumbnails in a YouTube video, but nevertheless, else probably the same technology if we had today was given to you, what would be your experience on that day? Also, what would be your reaction if you just saw the technology which was there today?
So if you see, we all get acclimatized by incremental technology, right? Um, Before you people were using smartphones, maybe you would have used uh, Nokia, N-Gage, or Blackberries and all. When smartphones arrived, yeah, you were amazed, but not flabbergasted, because you are getting incrementally exposed to advanced technology, right? So even we were also getting incrementally exposed to advanced technology. The next technology that would arrive would be a slightly improved version of the previous technology. Things were not flabbergasting. But if you take me to a fantasy world where you immediately give me a smartphone instead of a Nokia Desi mobile, then of course anybody's eye will pop out, like I also will be flabbergasted. So, but my reaction would be like that only. And I'll definitely say technological inventions that happen in the world are always incremental. Okay, that situation will never arise. Maybe in the next 50 years also, you will never see a technology which will uh, which will take a quantum leap, a giant leap from the existing technologies. You'll never see such technologies. Very difficult, actually. All technologies are, why it is like that? Because engineering or technology development is done incrementally. No? When the designers design something, they fail multiple times, and they understand why they are failing, correct it, and then develop it. And after they develop it, they understand in real world that there is still some limitations, though they plug it and create an improved version, right? Like that, improved versions keep on adding up. So always technology development is incremental. Okay, so yeah.
You talked about the increment of how the technology has grown up and how it as an experience is never that flabbergasting.
Hmm.
Let me just ask you this one question: is just experience enough to just solve the problem statement in machine learning? Like, let me just say a software engineer who has an experience in one technology for 10 years. Can he really solve a machine learning problem? That's my question.
The question here is, can he solve, or can he solve in a limited amount of time,
Yeah, both.
or can he? Okay, I would say it's difficult for him to solve in a given limited amount of time if he's not exposed to a new subject. But if that guy has a zeal that he will learn the new subject, take control of the subject, and then work over it, who stops him? Tell me, right? Who stops him? Ultimately, when I started in IISc, I was nothing. My advisor thought that I'll do nothing, but nobody stopped me, right? See, it's not the question of a human potential. See, if you get a new ML project, let's say, and the client says that you have to finish it in 3 months, you have a guy who's working in .NET or Java platform, ask him to finish the ML project, definitely can't finish it in 3 months at the level of your expectation. But if you ask him, give him sufficient time, let's say a year or something, to get trained well, and he really wants to put his all effort to get trained well, he has motivation, he has perseverance, everything, and then he comes back after the next 1 year, and you give him a new ML project, and definitely he can finish it in the next 3 months. Okay, human potential you cannot underestimate. Okay, that's my answer. Yeah.
Sir, I was fascinated because you were teaching probability and game theory. It's not the game theory, graph theory in as an professor, working in database and taking such subjects. I feel so you can answer this question in a very short or a long answer type. I don't know that, but what's that influence of probability in the technology today?
Okay, definitely. Your recommender systems are all based on statistics and probability. Okay, your smart traffic controlling systems are all based on statistics and probability. Your initial medical diagnosis is now happening because of probability and statistics. Your neural networks works on probability and statistics, right? Your classifier, support vector machines, your clustering algorithms that you use in population analysis, uh, your marketing research. Most of these MBAs do marketing research, right? Marketing research to understand, is there a demand for a particular product? That's also completely probability and statistics, where there is no impact. There is impact, but what I will say is that uh, it does not usually become a sole technology. It supplements the technology. I would always say like that. Statistics supplements the technology to make it better, rather than becoming a complete technology in itself. You cannot sell a technology that it does some statistical things. You have a big technology, statistical component goes into it to make it better. I would say like that.
Sir,
Yeah.
you told about statistics. What is statistics according to you?
See, statistics, there is a difference between statistics and probability. People should understand what is statistics. As I told you, statistics is information about data. Okay, data is information about real world.
But
Statistics
it's
is
really
information.
different today because we have inequalities involved in it. You take new way of math, there are Lie groups, there are MLH models which have been come out. Heuristic model have also been much more in the influence today. What is statistics according to you?
I would say statistics simply it is metadata. Metadata means it is information about the data you have collected, right? Okay. Knowledge. I'll not say it's knowledge. I'll say it's knowledge about the data that you've collected. Let's not use the word information. Information is direct. Knowledge has to be extracted. So statistics is that extracted knowledge about the data. Understand? Yeah? So, for example, you might have extracted what is the probability distribution of the data, the frequency distribution of the data. That is statistics. So, when you have a data, you sit and extract knowledge. Knowledge becomes statistics. And what is probability? Basically, probability is a measure. Best thing is, I'll say, you have a measuring scale in shops, right? You put your vegetables on one side, you put the weights on the other side, you measure it. That's called the measuring scale. You can think probability as that measuring scale itself. It's a measure. It measures the chances of certain events to occur in future. Understand? Okay. So when you put an event on that measuring scale called probability and ask it, it will say, okay, there is 70% chance that this event might happen tomorrow. you know. So it is a tool of statistics, I will say. Even probability is a tool of statistics. Why? Because it extracts knowledge by using the data, right? Yeah, get it.
So, you have worked on database, and
Hmm.
big data became boom, I think probably 2016, 2017 odd. But you have
Hmm.
worked on data before. Like, how is it different from dealing with data then and now?
Data has become more unstructured today rather than back then. Data was like structured data, RDBMS, where you have columns, rows, tables, relations, everything. Well, everything is structured. You play your game. But today, structures data is unstructured, text files, unstructured data. It's not organized into tables or relations, and huge amount of data is collected today from your social networks, from your devices, everywhere. That is the challenge today. You cannot structure the data in a given time format. You have to operate on unstructured data. Now you want to do all the analysis that you're doing on RDBMS, you want to do it on unstructured data now. But you cannot do it easily because it's unstructured. You cannot store the unstructured data in RDBMS. It's a no use. So that's why nowadays I feel um, there is a computational challenge in harnessing data today. I would say always computational challenge is significant today in harnessing the data, yeah, or exploring the data. Yeah.
Will we have a statistical approach which has never worked in the future, or else is there anything in statistics that has not worked? Turing used to always say that even though there is a false fallacy, I'm not quoting it, even though there is something which is being predicted false, but it's not a dumb model. No, I just wanted to ask you one question, sir. Are we adamant to the potential of what algorithm is all about?
Can you repeat the question?
Are we adamant to the fact about the potential of a simple to a complex algorithm? That's what I reframed it.
Are you adamant to the?
Are we adamant to the fact that about the
Hmm,
potential of an algorithm? When I see AlphaGo, which was
hmm.
developed for alpha beta pruning algorithm, and all these things have come out, are we adamant to the fact
Hmm.
about the potential of an algorithm? Or else are we just focusing on just technologies which just going to give us marks, or else probably a good job? What's your view as a professor?
See, I'll definitely say, see, algorithm is used in building a technology, right? The business is in the technology, not in the algorithm. I'm very particular here. Okay. Nobody understands your algorithms, right? Yeah, everybody is focusing on technology, what it can do for them, what features it has. So I would always say, if you look at a business aspect, if you want to give better technology, if you can give that better technology by using the existing algorithms, then fine, use it. But if you do require new algorithms to be designed, or you have to improve the existing algorithms, then fantastic, you have to do that. Okay. But I would not say that you will a new algorithm that you propose will necessarily create a new technology. I will never say like that. Or it can create a very big business potential. That's a very wrong way to look into it. It is a top-down approach. New technology, if it wants something, then it can create a possibility of improving the existing algorithm or proposing a new algorithm. For example, uh, until in classical CS, we had all these graph search algorithms, right? We had what do you call that? Uh, minimal paths traversals. You have the Prim's algorithm and all those things were there. But immediately when you see these graph traversal algorithms like Prim's, Kruskal's algorithm, all those things, or Distra's algorithm, they are very classical ones. Fantastic. Many technologies were developed using that also. But suddenly when you saw mobile networks coming into picture, especially mobile ad hoc networks, when they where the nodes are having dynamic connections. At one moment, some two nodes are connected, next moment they're not connected because of the proximity. Now here you cannot use that classical graph traversal algorithms to transmit the messages because the edges are very dynamic. Then a new concept came into picture called random graphs, probabilistic graphs. The same graph traversal algorithms were now being redesigned in a probabilistic fashion. Okay. So this new technology demanded a new algorithm. You understand? So quite often in the world, new technologies demand new algorithms, and then of course new algorithms come into the world. Okay. Yeah.
Sir, when you said about new algorithms come into the world depending on
Mm.
the old algorithm or the old technologies, Jitendra
Mm.
Malik, one of the prominent scientists in computer vision, says that if you want 99.9% accuracy, work for 5 years. That means if you have a PhD problem statement, you have to work for 5 years. That's for sure. Like, what should be the work that we should be doing in order to get artificial general intelligence into the world, or else
To what
making
extent?
it more accessible to the world?
Okay. See, artificial intelligence is something people don't understand here. There is a limitation there. Many people have thinking that AI will end up creating a Terminator-like movie. You know, in '92 when Terminator movie was released, I think you've seen all the Terminator series, right? It's all based on artificial intelligence. The great director, what was his name, James Cameron, when he came up with Terminator 1 in 1982, he thought of artificial intelligence back then. Can you imagine? Thinking robots which will be developed to such extent that they'll become humans, behave like humans, and start a world war with humans. And Terminator 2 is the best Terminator movie ever made among those all those five Terminator movies, 5 or 6 movies. And when we were 92, when we saw it in a movie theater, we just out of the world experience. But one thing you must understand: at the end of the day, computing works on a discrete world. Discrete world. The world where entities are clearly identified. You understand? It does not work in a continuous world. We humans work in a continuous world. If I give a new situation, your brain can react to it in a certain way based on its own experience. You understand? A new situation. A computer or a AI system cannot react if it is not programmed to it. You understand? Yeah? That's why if you see driverless cars, quite often go and crash. Why do they crash? Because there are new instances coming which they are not trained to work on. Okay. Unless we make computer systems operate on the continuous world rather than the discrete world, you cannot imagine AI becoming 100% like humans or 99% like humans. That's a very difficult thing. And neither you can do it because your computers are built by discrete entities. You build your computer by taking each transistor, right? You have billions of transistors, but all those billions form a discrete set. They're not a continuous set, right? But your human mind, even though it's made up of neurons, it is capable of operating in a continuous world. You know, it just give a new instances, you know how to react to it. If I show you a new car, you have to dodge the new car, you'll easily dodge it. You know, that's how it happens. So that 99.6% accuracy in AI, while making it an AI system behave like a human, is, I still believe it's not a feasible dream actually. And many people have tried it. Thousands of people are trying it, and it cannot happen. To be frank, it cannot happen. So, of course, AI systems can be made 99.6% accurate in doing one job properly. For example, now you're doing robotic surgeries. They are doing better surgeries than normal surgeons. Right? One job, yes, a AI system can perform better than a human. One job. But if you ask like a human to operate in any new instance in an open world, it cannot. Yeah.
No, basically, we have been losing a lot of ethics in AI systems
Mm.
also. But, like, what do you
Mm.
feel about AI alignment and quantum computing or any
AI
other
alignment,
AI alignment?
alignment with other fields
Yep. Yes, sir.
like quantum computer.
Yep.
Yeah, quantum mechanics has been pulled into CS and AI also nowadays. But um, AI has gone into economics today. Oh, no, come on. Rather than AI getting benefited from other things, all the disciplines are getting benefited with AI and ML, to be frank. I have not seen one, even movie industry is using AI ML today, right? Even historical research is using AI ML. There are many artifacts found in Mexican Valley about the Aztec civilization. Some are broken, some figures are broken. Now they want to complete it. They are using AI and ML to cover it up. You know? So, historical research, archaeological research, movies, medicine, any field in the world, everywhere we are getting benefited with the AI ML. And definitely AI ML also gets benefited by statistics, mathematics, and quantum computing. Again, you must understand, is a computer that is built not by transistors but by using atomic particles. Okay, you don't have the engineering to control these atomic particles at a large scale, right? At the atomic world, you have the quantum mechanical laws governing that world, where it's not like classical world. Like when I'm talking with you, you are sitting in front of me now. In quantum world, you will be sitting in almost every part of the world. Okay, it's not that you're just confined here. Okay, you appear to be confined here, but in reality, you are everywhere. Okay, that is the quantum mechanical world. And how do you control elements in that world by using classical engineering? It's difficult, right? It's also a fantasy dream now to build a quantum computer. They say they have built, but it's very minutely. It cannot be done in a large scale. Yeah.
You talked a pretty awesome way of how quantum computers can be in the future. Like there is a lot of layers of abstraction, there is a lot of technological improvements which we have witnessed as a human, not me. I've been living in this world from past 21 years. Probably 5 years is like bonus. Probably 16 years is the experience of me working with some of the other forms of technology. Do you really feel that software and hardware architecture is just working on stashing hardware and software into one such component? And also, do you think that it's an overkill?
Mm-hmm. Okay. Yeah, today computer systems are all about hardwares and softwares combined together, right? Yes, looks like that today because invariably we have to deal with hardware and software. You develop better materials and hardware to help your software work better. You understand? We can't think of the third one here. Uh, yeah, invariably computing systems for a long run now will be still be dealing with hardware issues and software developments. Okay, that we cannot escape invariably. Yeah,
Sir,
yeah.
lastly, this is the last question of this podcast. What is that X factor that we have lost today as a student?
Yeah, this is what I want to talk. Is very important also. As a student, if you see, back then when we were students, we did not even have proper. We did not have teachers teaching many courses. Like there were hardly in a semester there would be one or two teachers coming and taking the class, one professor or two professors. Largely, we were doing self study. Now, I want to tell to these youngsters, yes, ambition, getting a zeal of developing new technology. Most of the capable youngsters today, capable, intelligent, high achieving youngsters, when they enter a technical school, what do they think? I want to start a company. I want to have a startup. I want to become millionaire very quickly, because you have so many examples around you. Oyos, Ritesh Agarwal, right? All of them have become multimillionaires in 25 years of age,
Overnight.
right?
Overnight
Overnight,
is the
all of
word.
them driving Ferraris, Lamborghinis, and everything. Fine. I would say fantastic. But in fact, when I had given a seminar in Bangalore Exhibition Center once, a guy who was a IRS officer, Indian Revenue Service officer. He was also a doctor, and now he did his IRS. Now he's working as IRS officer. His son was 18 years old. He did not want his son to do engineering. He wanted his son to become an entrepreneur as quickly as possible. You know, he's asking me, I don't want him to waste 4 years in technical school. Let him start, learn some technology quickly online and then start establishing his company. This commercial mindset has gone too much now, in fact, among the youngsters. I would say it is good also. I would say it's bad in another sense also. I would like to advise all youngsters. Yes, the dreams the youngsters have in establishing great companies, quickly becoming millionaires or billionaires is fantastic. That's the main motivation. However, the fundamental training cannot be overlooked. Okay, there are four pillars in CS. I'll talk only about CS. One is mathematics, another is statistics, another is algorithms, and fourth is programming. Okay, programming. Mathematics, statistics, algorithms, and programming. Every youngster who is doing a CS related degree, anything like that, these four pillars have to be properly established. Whether you want to start a tomorrow's OU or you want to start SpaceX like Elon Musk, doesn't matter. You cannot overlook these four features, four foundations. Be very well thorough with mathematics, be very thorough with statistics, be very thorough with algorithms, and be very thorough, very capable with programming. You should be able to do any kinds of complex program. Okay? Especially when I am teaching my students, especially master students, every chapter I'll give programming assignments. I tell them to get acclimatized with as much as possible with programming. Okay? And when you are very strong in these four pillars, you will have so much confidence in life. I'm telling you, you will never be unemployed. You will never fear of losing jobs. You will always confidence. You will have so much confidence in you that you'll always think. You will always feel that you will always get that great amount of money whenever you want. You know, because you are capable. That capability will give you that inherent strength. You know, and how does that capability come? When you fix these four foundations very well. Okay. I have seen personally in my life those people who are very strong in these four pillars are enjoying this world like heroes. They are neither worried about job loss, lack of jobs, nothing. Opportunities come to them, they do it well, execute it well, and more opportunities come to them. They travel the world, they enjoy their life. It's very important. Okay, so spend your early years of life, maybe 4 years or 8 years, being strong in these aspects. Okay, once these things are properly established, whatever big entrepreneur you want to become, you become. Okay, and it's so easy to become, very easy to become. I have operated a company sitting in my bedroom. Okay, and successfully I have operated it for the last 4 years. Okay, and I had people standing in the waiting list pleading me to take their projects. Okay, and I'm not one example. There are many examples like me in Bangalore itself. My friends, many of them. So youngsters should never overlook foundational training because that is ultimately what will give you your bread and butter. Okay. Always remember mathematics, statistics, algorithms, and programming. Always. Okay. Be very strong in them. Yeah.
Thank you so much, sir. It was amazing talking to you. And probably this is going to be one of the basic way in which they can really understand what computer science is all about. It's not about going too complex, or it's also not about getting in them fascinated about the new tech, but the way you talked about how the technology is going to disrupt the market and how the technology has to be and how a technician has to build himself in the future. I think this is going to give an overview on what people can think about in future. Thank you so much for this podcast, sir.
Thank you so much for giving me an opportunity. I hope it reaches many friends and students who can
Yes.
benefit from it, even a slight benefit from it. I feel that I have done a good job. Okay. Thank you.
Thank you so much, sir.